The recurrent laryngeal nerve is not an example of bad design, it is consistent with good design. In discussions about the human body and its anatomical structures, one of the recurring arguments posed by proponents of evolution against intelligent design is the concept of bad design. A frequently cited example is the recurrent laryngeal nerve, RLN, which follows what appears to be a needlessly circuitous route in the body. Evolutionary biologists like Jerry Coyne and Richard Dawkins argue that such a route is unintelligent and provides evidence that the nerve's path is an evolutionary leftover from our fish ancestors. However, upon closer examination, both from a scientific and philosophical standpoint, the recurrent laryngeal nerve actually exhibits a sophisticated and functional design that is consistent with good design principles. Developmental constraints and functional necessity. One of the central reasons for the RLN's path is rooted in the developmental dynamics of the human body. As Professor Eric Blechschmidt noted, anatomical features like the RLN cannot be fully understood without considering the necessary consequences of developmental dynamics. During fetal development, the human body undergoes significant changes in shape and form. The heart, which initially develops in the neck region, gradually descends into the thoracic cavity. As it does, various structures, including nerves and blood vessels, elongate and adjust accordingly. The RLN, rather than being a design flaw, is shaped by these developmental constraints. It loops under the aortic arch in the chest and then travels back up to the larynx. This longer route is necessary because of how the body elongates and shifts during development. Eliminating this route, or significantly altering it, would interfere with the body's ability to function properly at every stage of growth. Living organisms must function throughout development, unlike human-designed machines that only need to function after assembly is complete. Thus, the RLN's design reflects an intricate process of development, one that allows the nerve to continue functioning throughout the critical stages of fetal growth. This design cannot be dismissed as an evolutionary leftover, but must be understood in the broader context of developmental biology. In fact, human-designed systems, such as radios and computers, also have non-direct routes for wires and circuits, but these paths are necessary for the overall functionality of the system. Similarly, the RLN's path is an optimal solution for a functional system that must operate at all stages of life. The RLN's multifunctionality, more than just the larynx. Another important aspect of the RLN's design is its multifunctionality. While critics focus on the fact that the RLN innervates the larynx by traveling a longer path than seemingly necessary, they often overlook that this nerve also innervates other critical organs. The RLN provides innervation to the heart, esophagus, and trachea, among other structures. This multifunctionality is a hallmark of good design, as it maximizes efficiency by allowing one nerve to serve multiple purposes. The argument that the RLN is inefficient because it does not take the shortest route to the larynx fails to appreciate the complexity and interconnectedness of the body's systems. The RLN's path allows it to serve multiple organs, a feat that a more direct route would not achieve. The body is an integrated system where many components must work together harmoniously. The RLN's trajectory, far from being a sign of poor design, is an example of how design in biological systems must account for multiple functions simultaneously. In this way, the RLN's design actually reflects an economy of structure, a principle often seen in intelligent systems. Redundancy, a sign of good design. Another argument against the claim of poor design is the presence of redundancy in the innervation of the larynx. The larynx is not solely dependent on the RLN for its function. It also receives innervation from the superior laryngeal nerve, SLN, which directly innervates the larynx. This dual innervation provides a backup system in case one of the nerves is damaged. Redundancy is a well-known design principle that increases the reliability of a system. In engineering, redundancy ensures that if one component fails, the system can continue functioning. This principle is evident in the design of the larynx's innervation. The dual roles of the RLN and SLN show that these nerves serve distinct purposes. The RLN primarily affects lower-pitched sounds, while the SLN affects higher-pitched sounds. This separation of function ensures a broader range of vocal control. In the event of damage to one nerve, the other can compensate, allowing some level of functionality to be maintained. Such a design is far from inefficient, rather, it reflects a careful consideration of both function and contingency. Embryological complexity and good design. Embryological development further supports the case for good design in the RLN. The nerve's trajectory is not arbitrary but is influenced by the movement of other structures, such as the aorta and the heart, during fetal development. The complexity of this process shows how interconnected and dependent various parts of the body are on one another. The nerve's route allows it to maintain connections to important organs, even as these organs shift position during development. Moreover, research shows that the RLN plays a role in supporting the development of the ductus arteriosus, a vital blood vessel in the fetus. The RLN provides mechanical support to this artery, which is crucial for proper lung development before birth. Without this support, the ductus arteriosus would not develop correctly, leading to serious health issues after birth. Thus, the RLN's path serves not only its adult function but also critical functions during embryonic development. This is further evidence of good design, as the RLN is optimally positioned to fulfill multiple roles throughout different stages of life. Conclusion. The RLN is evidence of design optimization. The argument that the RLN is poorly designed assumes that a better design exists, a claim that critics of intelligent design have not substantiated. As with any design system, trade-offs and constraints must be considered. The RLN's path is a product of developmental constraints, functional integration, and redundancy, all of which point to optimization rather than inefficiency. The nerve's multiple functions and its role during both fetal development and adult life demonstrate that it is an example of intelligent design. Critics of intelligent design often overlook these complexities, preferring to focus on perceived imperfections. However, the presence of design trade-offs does not negate the idea of good design. In fact, the RLN reflects the kind of optimization that we expect to see in systems that are carefully designed to balance multiple needs and functions. The RLN's trajectory, rather than refuting intelligent design, showcases the intricacy and foresight involved in the design of the human body. Far from being an example of bad design, the recurrent laryngeal nerve is consistent with principles of good design that prioritize functionality, redundancy, and developmental necessity. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.